Okay, so we just got done recently graphing distributions and tables at the same time when having data, because otherwise we have big data and you have to figure out how to do it, and also learn how to graph different distribution given a table. I'm going to recap on that again today, right now, and that's as we go ahead and graph about different distribution and given different distribution. Okay, so going further beyond that, sorry, this should be good now. So going further beyond that, what we're definitely seeing here is we're going to be graphing the histograms that correspond with the relative frequency distribution and the percent relative frequency distribution. We're going to be doing those guys. So let's go ahead and get started with this so we can see what's happening. Okay, so over here we're definitely seeing our frequency distribution table. So typically we'll see like this, and we're asked, okay, make relative frequency, make the cumulative frequency, or relative frequency percentages, and also look at cumulative frequencies. They might not see about cumulative frequencies. But let us first recap on how is it that we could graph a frequency distribution given the table, not by given the data. So we're definitely seeing here is, well, in order for us to do this, we have to know two important things. Well, first thing is we need to know our lower limit, because that's what we're going to be putting into the CASIO. And also, we're going to ask for us to put in the class width, or aka interval size. So how to do that? How do we get this 15-inch right here? Well, we should recall. How before how we get the 25 was we got the 10 and added 15 to it, got 25. And when we did the same over here, we added 15 again. And we got 20, and we got 40. So if you see the pattern like that, you can see it right away. But let's say we don't see that pattern, what's a good approach to doing it? Well, it's not, where we really don't look at intervals, because remember, the class width is what helped us gave us the lower limits, which are the lower limits. So we have to make sure that we can get the lower limit, use lower limits to get it, or some people refer to it as the boundary points, boundary points. But either way, the both would work either way. So let's go ahead and get the class width. Class width. So we're going to go ahead and get the difference of the real limit our limit, I usually write RL for short. Get the limit, which once again these are your lower limits, your two consecutive lower limits. So the two consecutive lower limits you see there are 10, 20, 5, and 10. Those are the two consecutive lower limits, aka real limits. So when I subtract the two, I'll end up getting, in this case, 15. Ultimatum is, if you knew the boundary points, which is also something that could have happened here, we could have got the corresponding boundary points for them. Well, we knew that over here could have been 9.5 for a boundary point, BP. Once again, BP is boundary points. And over here, we already had 24.5. So if you want to use boundary points, it would still work. If you want to get the difference of the boundary points. So you can do the same thing here, which is 24.5 minus the 9.5, and same thing happens when we subtract, you're still going to get 15. And you can calculate for that. You don't have to really do it by hand. I just literally did it by hand, so it's easier for me. So come over here, I could now grab the histogram. We know if we do it here by hand, we have to know that either there'll be the real limits, which are the lower limits, ending with 85 over here, because that's the real limit, upper limit for this one. Or some of you guys might be doing the boundary. So remember, this technology does just pretty much literally does the real limits, but for sure if you put boundary points as a starting, it might be able to do it, but I never tried it, but I believe it will. It's a simple adjustment once you know the pattern. So over here was supposed to be 39.5, over here was supposed to be 54.5, and over here was supposed to be 69.5, and right here was supposed to be 84.5. Okay, so once again, what goes in the x-axis is always your variable, your measurement, which we're looking at in this case, distance, or not distance, driving time, and it's in minutes. That's what we're looking at here. So I have to get the boundaries in here, or real limits, whichever it is you're going to use. I'm going to use boundary points for this instance. So 9.5, 24.5, 39.5, 54.5, 69.5, and 84.5. So the equally distance, that's good. And as we did before over here, we had our frequency distribution, so about frequency. You can write it out or shorthanded. Usually you write it out because people might not even know what freq means. I'm just doing short so I can get through it quick. And last time what we used, even though 7 is here, sometimes 7 won't be here, so I showed you how we could change the scale and use numbers that are appropriate to it. Like we said, we went for the 8 or the 10, so we did it based off 2s. So over here, we could say here, scale is 2, and we went for the max y to equal, in this case, we went for the 10. Even though it will go higher, we went for the 10. It's about as greater than, we're giving 8 for the 7, or the 8 kills greater than 7. But anyways, I'm doing it last time, so 10, 0, 2, 4, 6, 8, 10, and obviously we go higher. And from here, we got the corresponding frequencies that came with it. Where's my color? Oh, green is red. Oh, there it is. So come over here, we just keep it consistent. So we went ahead and knew that our 6 were here in this line. So we pretty much made it as straight as possible. And then we, once again, 7 was halfway between 8 and 6. So we went halfway. Drops down. And similar with the other one, it was supposed to be 4. 4 is right here in this line, this grid line. So 4 was there. Then it was 2 on this grid line. And then it was 1 over here on this grid line. So we went ahead and got all those guys in, which was great. So now what we also did these guys, we know exactly what they are. 6, 7, 4, 2, 1. We just look more at 7. And there we go. We've got the frequency distribution. So once again, how do we do it using a calculator? Well, we have to make sure they're both on the list, first of all, and then from there. So if it's on the list, make sure you put it in the list before going on. So I'm going to turn this on. I'm going to go over to menu. I'm getting stat. I'm going to quit this, and I'll be list. So over here, you will notice how minus 1 minus 1 is corresponding to the lower limits of the interval, and this 2 is corresponding to the frequencies. So they're already pretty much up here. So what we do here is I'm going to now go to my graph, and I'm going to be setting graph 2. So I'm going to set, and I forgot to turn it on, so let me just second quit it real quick. Graph, set, I want it on, so I'm going to turn it on. And then once again, I could just go back with the exit, and I go to set. This graph 2, this is graph 1. I want graph 2. Okay, it's ready to graph 1. This 1 is good, but over here I'll do this 3. So I'll make sure I change that to this 3. So this 2. So I'm gonna do shift, list, or just over here, list, and you have to do it from here. Thank you, I'll just type it in. So there we go. That is there, ready to go. So what do we do now? Well, what we're going to do now is we just go ahead and exit this because I entered it, or make sure you press enter. And then now I could graph. So once again, it asks me what should be my starting point. I'm saying 10 because that's the lower limit, and 15 because that's the class width. So when I graph it, everything's good. I got my histogram. But notice how my scaling is kind of, if you were to see it, the colors it's showing that it's based off scale 5. So I have to adjust that to be what we have over here, which is pretty much compared to max of 8 or 10. We have 10, and we do rank scale 2. So how do you do it again? Well, go to view window, but it has to be shift view window. So shift view window. You keep that as a negative 2.5, but the max. That's we'll keep that the way it is. It's a scale. So I won't do too much of these guys. Coming over here, that's good. Right's good. There it is. So the max one would be 10. Enter. And the scale I want that to be 2. To be consistent to what we have over there in our graph. So when I do that, and I pretty much enter, I go ahead and go back to my graph, and I'm graphing 2, same restraints. And notice how this is looking more like what we have. We have the scales, the grid marks, and it's looking very, very similar to ours. And that's good. Okay. So we could always rescale the graph image by just doing view and make it to the scale that we want and the max we want, and it will work. Okay. So now let's go ahead and get to raw frequencies, and so we're going to see how when we're graphing it, this is going to have to constantly be rescaling. Even though the graph does rescale the graph itself, if do some zooming, the grids and the scaling for those guys is what changes. So we have to just adjust it and get it to adjust to what we want to do. Okay, this goes we want. So when we convert it over pretty easily. So the question is, how do we route the frequency? That's the first thing we have to figure out is what is route the frequency? How does it work? So come over here. We're going to go ahead and do that. So route the frequency. Actually, just one R for short. I'm going to do proportion, which is the first type. And it'll be for short. But I'm just writing out full right now. When I write it'll be proportion. So what we're getting to route the frequency in proportion form. We're saying that the proportion of values or other values is going to be pretty much the corresponding frequency in the interval or the class we're looking at divided by the number of participants or observations that we have. So therefore over here we have to know that number of observations really is the sum of all frequencies. So we're writing that down. We know we're talking about some of our frequencies should equal all the frequencies we have up there, which is 6 plus 7 plus 4 plus 2 plus 1, which here in turn will be 20. So you can do this in a calculator. It's very nice and very interesting how it works in a calculator. We'll see that very, very quick. But I'm going to come back here and say, okay, let's look at the first interval. And the first interval we have here is our class. We have happens to be 10 to 24. And we know its corresponding frequency was supposed to be 6. But if not, at the end, n was supposed to be 20. So if we're trying to find the relative frequency that goes right here, we're going to get the 6, and we're going to divide it by 20. This is simplified and becomes 1/3, or 3/10, which we'll be seeing when we do some of the simplifications over here, and the current sets we do. But actually it does equal 0.3. And we'll see that when we look at the calculator. So first and first, what we're going to see is, okay, I'm going to do this, then we say, okay, how can we do the sum? Because the sum will be an alternate way of actually adding this instead of doing it all by hand, which is really not that bad. This is pretty calculator. But anyways, now, what we're seeing here, that's how to put this in the calculator. So I'm going to come here real quick, and I'm going to exit the graph, so I'm going to show everything through calculations. So we're going to go to the run matrix. So let's go to the run matrix. So I'm going to do manual, and then we're going to run matrix, which is calculate with calculations. And if you want to get rid of all this, you could definitely do so. This is how we do it. You'll see delete right here. You can press delete and say, what, delete line? It'll be a line if they have highlighted, or do delete all. And when you do delete all, you can ask, are you sure? And if F1 if you're sure, F6 if you're not. And that's sure, so pretty much everything goes away. Now, what we do here, so I'm going to go for Algebra 31 for right now. And obviously, we know how to input this stuff in the calculator. I'm going to go with that. I'll be showing you the shorthand very soon. Okay? So, but before we do that, let's go ahead and do the relative frequency. So, what we said, all we do is 6 divided by 20. So, when I do it this way, in division formula like that, fraction, it becomes decimal, which is nice. Okay? Dr. made it, let's make a fraction bar. And that would use as fractions. Usually some components require a fraction bar, so we use that fraction bar. So the fraction bar is right here. So, oops, I didn't want to do that. It's very sensitive to my finger to touch. Fraction bar, so fraction bar occurs, and 6 goes in the numerator, press down, and 20 goes in the denominator. If you need to get out of the fraction bar or navigate, just go to the right until you can see the fraction. So that's there. Now when I do this, notice how it makes a fraction. We're like, oops, I don't want a fraction. I wanted the I wanted the conversion. I wanted a decimal form. But it's okay. There is a way to convert between fraction and decimal form or any type of syntax or script into decimals. And that is right here. Right next to it, we see S to D, back and forth. This means I can go between script to decimal, and decimal to script. I go back and forth. So when I hit this button, notice how 3/10 became 0.3. I press it again, it becomes 3/10 again. I go back and forth within it. So that's an alternate way of pretty much do things. Now, the next question is, how do I get that sum? First of all, remember, it comes from a list. The list we're focusing on is, in our case, it's supposed to be list 2. Guys, we'll use that. And that should be labeled over here. This one, this 2, because that's what it corresponds with. This right here was our list 1. And this was our list 2. So I can call upon list 2, and it will show the set here, and which is great. So when I do shift list and I press 2, I get the whole list back. And what it's saying here, if you're doing any type of list operation, it's saying that I'm gonna get everything on that list and I'm gonna do what it asks me to, either be operational on list, or be a mapped operation on list. There's two types of operating. One is clear operation, one is map. But on our graph, our calculator, it's all in one. Because look at the other one, just that how we use it is differently. So how do we do that? Well, notice how I have no list up here as an option. So I have to first press options. So I press options, notice how this comes up. That's great. I can press this. Now, when I press this here is all these are all the operations I will do in the list. So I don't see anything with sum yet. So I'm gonna forward it to the right. Still don't see anything with sum yet. So I'm gonna forward to the right again, and there it is, sum. This means sum of list. So when I hit sum, now I'm gonna put the list, but put it in parentheses, okay? You have to make sure you put it in parentheses. So parentheses, shift list, and 2. That's where this is coming from. And when I do that, there's my sum. Pretty interesting. So now here you might be thinking, okay, well, if I can do that, can I get all the lists in this 2 to be divided by the sum? And answer that question is yes, you can. You can do that. You can type 20, or you can do the sum operation, and which is going to be 20 still. So, but keep in mind, if you put it in fraction form, it should be fraction. If you put it in decimal form, it's going to be division form, it will be division. And I'm going to show both of them, and you can see what's happening. So over here, let me just do the division one first, then the fraction. So what I can do here, I can just do the list and then divide by the result 20. Then I'm going to do the whole thing. So come over here. I'm going to do list. So shift 2, or sorry, shift left, then 2. Then but most important thing, make sure you put in parentheses. You need the parentheses. So go in front of the list, put parentheses. And at 2, put parentheses, because that says I want to do the list first. It's order operations, find the list first. Then I'll divide, and then right here, I'll just divide by 20, because that's the sum. And notice how each one of them gets divided by 20, and it happens to be in proportion form, and decimal form. So let's say that we accidentally did fraction form, and see what happens. So now, let me consider fraction. So I'm going to do fraction part. And I'm going to put the list at the top. So over here, there's require parentheses because it's in the numerator, but if it's going to be one whole line, you have the parentheses. So shift list 2, and the denominator, I'm just going to call upon the sum. So I'm not going to put 20, I'm going to call upon the sum this time. So I'm going to do option, find the sum. Oh wait, it's not there. Options. That's not. That's it. I'm going to do it again. List, shift list 2. So what happens is quit it and then do it again. Over here, so get my options out. There it is. I'm going to do list, and then I'm going to find sum. And then this was once again the parentheses of list 2. Just like that. So in the box will become 20 because it'll prove that. But when I do this, it says invalid. And the reason being, it could be because of the fraction operation, because it turns out you can't really do it sometimes. So let me just see, I'm just going to exit real quick, and let's see if I just delete the bottom. So delete. And let me see if I put 20. Will it work? No. So over here, it turns out it says that fractional operation with the list, with doing the list, won't be helpful here, unless, let me see something, maybe because I'm doing something wrong. But for the most part, every single time I tried it, it never worked. But let me see if I keep 2 parentheses up here, it might be disproving me. Oh, so when it comes to list, we can't do fraction operation. It has to be division. So have that noted. Okay, only division can work here, not the other way around. So I'm going to delete this. But I'm hoping that what I could do here is maybe I can get this list here and I can convert. Let me see if that works. Oh, that's nice. It won't do the operation of division with the fractions, but it could convert with the SD. You could actually go back and forth. That is amazing. Okay? If I one part, but you can actually do it using the conversion. That's nice. So, and that happens in the list as well. So how can I put this in the list? Because we want to the list operations to graph it, right? And use information. Well, let's go back to menu and go to our graph. Stats. Press 2 or enter it. Over here, list 3, I don't need, that was computed frequencies from before, so I'm going to delete all this stuff back over here. Delete those guys. So once again, how to delete? Well, just make sure you are in the main menu. E2, just press exit, so you're in the main menu. Right, delete all, yes. And I'm just going to pick the same thing. Delete all, yes. Delete all. Yes. So those are all gone. So on this 3, I want to put the value frequency distributions. So I'm going to call on the list. But the list doesn't happen here, it happens in this. You have to be in the list operation. So now over here, I could do what I need to do. So I have to do my shift 2. Oh crap, wrong one. I pressed list, totally list. Delete. So once again, put parentheses, shift list 2, and I'm going to divide that by the sum, or simply 20. And now they're all there. And if I want to convert a fraction, I can just, it's not going to do it. That's nice. So clear this. I don't think it's going to allow us to do any fractions, conversions. So, let me just see real quick. Nope, it's not going to allow us to convert. Maybe because I did it wrong. What do I do here? No, see, it's not, it's just doing that. But that doesn't really give us fraction operation. So, don't worry about that. So that's it. Okay, so we got about the frequency out of the way with the proportion. So how does percentage work? Well, I'm not right over here, so I won't lose what I have. So over here, in list 3, if I put list 3 over here, we ended with about the frequencies that were supposed to be 0.3, 0.35, 0.2, 0.1, 0.05. Those were our lists for the raw frequencies. So we're at okay. So how do I get the percentages? How does percentage work? Percentage work is not that bad. What we do is simply, I'll put it in green this time, for about the frequency percent. We could pretty much, I usually just use that quick simple for percent, where you could write PRC, decimal point, or point. So over here, well, it turns out that it's going to be the corresponding relative frequency of each or proportion of each interval. But we're going to multiply it times 100%. Or once again, n is what we sum of all frequency. So what are we doing here? Well, we can just for each one, and it'll work if we need a calculator. Literally, I need a calculator. I'm about to read for this one too. What we have here is we're looking at 0.3, and if we times by 100, your calculator will say, well, 100%. Don't put the percentage, put 100. It's going to give us 30. We know that this is not shown. Don't put it. At the end, we know that, hey, it's going to be 30% because I multiplied times 100. But there's also a main of doing this, and that is converting. We can actually convert from a proportion to a percentage just by moving decimals, and vice versa. So we've got some converting mechanisms. So the first one I'm going to do here is I'm going to pretty much do proportion, and I'm going to convert it to percentage. So, and that's what we're doing here. We're going to see how we're doing this in routing, or how can we do it by hand. We get the 0.3. We know we're going to multiply by 100%. So what's really happening here is notice how the decimal will over twice to get over here. So what we're doing here is we move the decimal twice to the right, two places to the right. Anything that's blank, like over here, we can put zeros. So what we're getting over here is, after we have converted, we move it to the right, giving us 30%. where the zero, the decimal point is right after the zero. Okay, that's where it is, right after the zero. So that's how we can go from proportion to percent. We can also go the other way. And we can go from percent to proportion. We go backwards. So I could start with a percentage, and I could go and obtain a proportion that corresponds with it. It usually happens when you're trying to convert from percentage and get the amount of people, if you know how many were observed, how many satisfied a certain condition. It's sort of really what we're doing. Okay. So what actually happens over here is, let's say we start with 30%, so I'm going to keep the 30% over here. So what actually happens here is we divide by 100%. That's not actually what happens. We do the opposite. So over here is multiplication. The opposite is to divide, because we're going the opposite way. We're inverting it. So naturally these guys will cancel, these percents will naturally cancel. So what happens with the 30? What really happens within this mix? Well, what really happens within this mix that converts it to the proportion is we get the 30, and we first input where decimal is. Since the original decimal over here is right after the zero, the last integer. And then from here, we just move 2 to the left. So 1, 2, my point is now here, any open space, parentheses becomes 0, parentheses space becomes 0. So what we're looking at here is pretty much 0.30, which is the same thing as saying 0.3. So that's how we convert back and forth between proportion and percentages where we never need it. So now when we put it to the calculator, the conversion won't be too difficult. Okay? Or even by hand, because all we're really doing is, once again, we're just moving twice to the right. That's all we're doing. So we get this guy twice to the right. Well, that means it's going to be 30%. Twice to the right. Well, that means it's going to be 35. Twice to the right. Well, that means it's going to be 20. Twice to the right. Well, that means it's going to be 10. Twice to the right, giving us 5. So converting that is not too difficult. We don't necessarily even multiply by 100, but if we're going to do that all individually, that's a different story. Okay? Because we also can work between percentage and proportion very easily. Okay? So how do we put this in the calculator? How can we do it so we don't have to do a constant division or rewriting? And for the most part, well, over here, we just put in this board, we're going to have this board be the percentage about the frequencies. So, come over here. Well, I could physically write in 30, 35, 20, 10, 5. That's not too difficult. I could physically write them in. See, not too difficult. Or what I could do is I'll say, I don't want to do that. Then we just go ahead and get each corresponding proportions that come from this 3 and multiply by 100. And I would just constantly be doing this, to have the calculator do this constantly every single time. Even though we know we're doing that, we can just show that and have it done. What's over there? And the frequency table. You can't see my hands, but the camera's not showing it. But anyways, come over here. What I could do is I could say, well, let me put parentheses, list, shift, list, and I'm looking at list 3. So I'll put 3, go to parentheses, and I'm going to say times each one. Oops, wrong one. Delete. Times each one by 1%. That's 101. Just fix that. Delete. 100. Enter. Wait, what did I just do? Something wrong. I must have added. I have add. That's what happened. I thought I changed it to times. Let me clear this. This is wrong. Or just go back up to this. It's going to fix itself. So come back over here and put it again. List 3, and I want times. Make sure it's times 100. Don't read it me and put addition. I think it's times. And there it is. Remember that. So, how do I graph this? How do I graph the frequencies? Well, we have to understand here is we're going to notice that when we graph each one, the shape doesn't change. The shape of the graph does not change. What's really changing is the scaling, because we have to adjust to the scales to make appropriate scales. So the graph won't be misleading. We don't want misleading graphs. So how do we adjust? That becomes the question. So what we do here is I'm going to give each graph up here in the calculator a different frequency relationship. Once we can have the regular frequencies, which should already be there, but I think it's graph 2, maybe graph 1, I'm going to check. And the other one, I'm going to give the proper ones. But before I even do that, over here, I'm going to note that the percentage drop the frequencies was list 4. So I don't want to mess up there. I want to put that there. So let me just go ahead over here and put them in. So here we go. I'm going to quit this, shouldn't quit, make sure I have the graph. I'm going to hit graph, and then pretty much, first thing I'll make sure I turn all of them on. So I'm going to turn this graph 1 on, graph 3 on, go back, and now I'm going to set each one of them. Okay, so for graph 1, I want this one to be the frequency one, so I'm going to adjust it so that they're frequencies. So I'm going to do that right here at this time. So first of all, it's supposed to be histogram, so I'm going to highlight that. Make sure I select the histogram. Histogram, good. The list of x's should always be the lower limit at this time because that's coming from the chart, the distribution table. So this one, I did it everywhere. Hit this one, enter. The frequency, we're going to let that be the regular frequency which we had before, which is just going to be at the L2, which is the regular frequencies. So I'll make sure I put this and choose 2. So that one's set. We're going to throw this one no more. So what I'm going to do, I'm going to go to the top, and I'm going to select graph 2 and adjust this appropriately. Over here, we have the histogram, great. This one, cool. But I want this one here to go proportions. So over there, proportion is supposed to be L3. So I'll make sure I change this to this 3 by hitting this and saying, no, you're 3 now. I have adjusted it. Okay. Now we'll go up to the top again. So I have my graph selections, and now I'm going to choose graph 3. Make sure it's a histogram. It is, great. The list should be the lower limit. That's great, the figure should be 4. Okay, but that one is good. I don't have to make any changes to that one, so we're good. If you need to make changes, make your changes, okay? Make sure it should be this 4. So, now, I could go ahead and quit this, everything's good. So let's go ahead to the first graph, that's one we just got earlier. And I'm gonna keep the starting and the width the same. And that's what we had earlier. That was the graph. So that one's there. Let me go back and graph the other one. So now I'm going to graph 2. Keep the same width, because that's sorry, we didn't change any of that. We're not changing any of that. We're just going to be resizing the scale of the frequencies. Now notice how it is this. It looks the same, but here's the issue. If you look over here, where's the scale? I see no scale. Remember, for proportions, we should be noticing that all the proportions are some value between 0 and 1. So these guys are nowhere close to being there. So we have to rescale it. We have to be able to rescale for the proportions. So right here, I'm going to do the proportion scale, and then I'm going to move off to the side a little bit and do the other scale. Go here to the proportion. So put pro. For now, proportion scale. And you clearly see that over here, the maximum is 35. So I could look to do 35 here or 4 if possible. So I usually try to go above if possible. If not, stop at it. So over here, I'm going to aim to do 4. 0.4. And the scale, notice how I'm in the 0.5ers. So because I'm here, I'm in this region, the best thing for me to do is to do a 0.05. So I'm looking at a scale of 0.05. So I can know, I can be at least accurate towards this round. So that becomes my new scale that I'm going to do. And we're going to do that over here. And then now we can see the grid marks come in when I change it. So once again, how do I change my scale? Well, I go to view window. So I have to shift B window. The x's are not changing because that's still consistent between the boundaries. But over here, the y min, it has a negative, so that's not that bad. We could keep it like that. What I was going to do, because I have a scale of 0.05, I was have that would be kind of the same thing. So I was going to say, let's let u be 0.05, and now that's entered. The max, it wasn't 0.446, it was, I want it to be 0.4, so I could adjust that, and I just put 0.4, enter, and the scale wasn't 2. Remember, our scale is supposed to be very much smaller than 1, so therefore, I'm going to make, like I have over there, I'll make it be 0.05. So I'll put 0.05 as my scale. Now enter, and I can enter one more time so it goes back. And over here, all I gotta do is graph. Now go back to graphing 2. Keep that the same. Now they come in grid. If you were to notice, I now see my grid marks right here. And these are all based on 0.5s. Look at that. These are all based on 0.5s. And it makes sense because right here is supposed to be 0.25. 0, 0.5, 1.1, 0.15, 0.2, 0.25, 0.3, 0.25. So now this grid scale is good. So now if I want to capture this image, I could capture it and I could export it to the computer. So now we have a perfect graph. So coming over here, now if I want to graph this by hand, that means I have to do adjustments. I have to really adjust scales. I didn't adjust any of these guys, I adjust the frequency scale. So first of all, instead of saying frequency, it's going to say relative frequency. I will run proportions on this side, and I'll be putting percentages on this side. So we can see how the graph don't change. The shape, the distribution of shape, it's the scaling that really changes. So over here, it's supposed to be the relative frequency. So val frequency, and over here we're looking at the proportion. So we don't necessarily have to write proportion for the most part. If you're showing that all these guys, the levels right here are less than 1, so it does become pretty obvious in nature in the future when you see proportions, we should better identify them. But over here, let's go ahead and do the same thing. So I'm going to do the same scale, aim for this max. It's not going to happen, we're going to aim for this max, but I'm going to have the scale. So over here, we have our 0. Then we'll put our 0.05 right here. We have our 0.1, my 0.15, my 0.2, my 0.25, my 0.3, and my 0.35. Like for us, the max has the 3.5. So we're lucky here. I don't really need to rescale it. So what I have to do is I'm gonna have to raise what these guys are here because these are not going to match. These are not matching. So I have to raise the rectangles and redraw. And that's one thing we have to worry about now. It's just a redrawing. So here we go. For the first interval, it was supposed to be 0.3. So we go to 0.3, the line's right here. So we have it go up to 0.3. And we make sure we drop it down. Or pull it up. Next one was 0.35. So that's okay. So I'll make sure it goes to the grid line, and I'll drop it down and make sure I have a rectangle. Draw. Next one over, it's supposed to be 0.2. Well, 0.2 is right here on this grid line, so I'll make sure I draw my rectangle for it. Next one over is going to be 0.1. Well, 0.1 is on this grid line, so I have my 0.1. lastly, 0.05 is on this grid line, so I can have a 0.5 go there. So we can now draw the proportional ones. I want to draw it right over here, this one. R is running both on the bottom, I won't have specifically here, so I might as well just do top, for now. Don't worry, the proportion will change. This will be released pretty soon. But over here we have our 0.3, in case people need to see and read it, because something might be guesstimation, so it would be good for them to know what it is. 0.35. Over here we have our 0.2, our 0 up here on top, because that space, my 0.2, my 0.1, and my 0.05. So I usually go top so it will be consistent in terms of it. Well, I'm going to work with that right now. I'll let it go back on real quick. But over here, I have this setup. Okay. So we rescaled it, and now we can see our graph. We can see, hey, I have the same distribution that I had before. The only difference is the scaling will change. The scale changed. Not the shape. The shape is still the same. So let's say that we want to do proportions, right? And you want to do on this side, instead of doing proportions, you want to go with the I'm looking for, the word I'm looking for is the percentages. I could definitely, on this side, I could write about the frequency. About the R. And over here, we state that it's a percent. And what's going to do about the frequency, and those are scales between 0 and 100, we already know, hey, you're referring to the percentage one, because percentage is always between 0 and 100%. Well, proportions are those between 0 and 1. So we didn't, most of the time we don't have to put percent and proportions, because just based off the number of the scales we're using, we can see which one it is. Over here, just to keep consistent, over here we have the 0, and once again, all we're doing is moving this over twice, 1, 2. So here it's going to be 5%, 317, 1,